Our next presentation at the IP Showcase for NAB 2024 is from Nir Nitzani from NVIDIA, and he's going to be talking about IEEE 1588, also known as Precision Time Protocol, for cloud AI. So take it away, Nir.
Thank you, Wes. Thank you very much. Thank you everyone for joining us today, all of you. So I'm from NVIDIA. I'm the product manager for a number of products. Part of them are related to our timing solution. Part of them are for the media entertainment. And today we are going to speak a lot how to combine this timing and cloud AI. So there is a lot of buzzwords on AI today, but let's see how things are connected. So as you can see here, we are going to talk about what is the data center, how things are connected, PTP in a nutshell, really 101. We are not going to get all the details of the PTP. AI of the data center, synchronization and stuff like that. We are going to touch base very soon, okay? Okay, so what we are discussing today, okay, is the things that you're already aware of, where PTP is already been said. So you know that PTP we have in the media entertainment. This is why we are all here. Oh. Well, we are all here. We have it in the 5G. This is the telco, or one specifically. Financial are really using PTP for very accurate transaction. And of course, in the cloud itself. Okay. Today we are going to concentrate in here, in the cloud. What can PTP provide in the cloud, and in specific for AI? So just to recap, until like years ago, NTP was the networking time protocol was the dominant. But as you know, it's provide you an accuracy of tens of hundreds of milliseconds. And we, of course, by using PTP, you can reduce it to a nanoseconds of accuracy. Okay, and this nanoseconds of accuracy is really crucial for some of the data center topology that we will discuss. So there is a transition moving in the data center, moving from what we called traditional one, okay, that we have a NTP based to PTP based. You need to have something like a one PTP entity that will drive the entire center, the data center. Everything is based on the grandmaster. Everything is connected together, so everything is a wall time clock. So this is simple, okay? PTP 101, I'm not going to get into all the details, okay? But this is the protocol that we are discussing today, or been using it today. You have what we call the master that starts all the synchronization between the other nodes, and the nodes are the slaves. In this case, there is a way of what the master is sending, the sync packets, okay, and how the slave is getting these packets from the timestamp that is reaching and receiving from the master. He can calculate the exact time that we currently have, the accuracy that we are having. This is really crucial to have a very, very stable nanoseconds accuracy of timestamp. By doing that, you can also measure not just the time and the accuracy, but you can also measure the latency of the network. Okay, that means that you can see what, for example, how long it took me, for example, from one node to the other node, from the master to the node, and so on. You can understand what is the topology of the network, and you can measure the entire time of the network, the time delay of the network. This is something that you can collect as a monitoring and telemetry, and use it for the data center topologies. Okay, now we are getting into AI. So we are trying to combine things. So we just talk a little bit about timing, or PTP. Like I told you, it's like very close, very, very fast. But on AI, let's dive a little bit in, okay? So these are, what we are looking at here is from data preparation to deployment. When we are talking about AI, okay, there is the first phase, collecting all the data. Think about the amount of data that you need to collect. This is the first phase. A very good example will be a Tesla car. Okay, Tesla car takes videos all the time. These videos are going to the data center. This is a data acquisition. This is where we are collecting a lot of movies, and from the cards itself, it can be the data itself from the video cams. It can be from an analytic statistic of the data, or what the driver has been doing. All of this is being collected, tremendous amount of data. This is the first phase. The second phase, the data curation, is to try to process all this data. Try to take from this data only what is important. You can think about it as from raw material to something that we can learn from. This is this phase of the data curation, okay? Now we're getting into the part of the pre-training. Pre-training, again, we still have a lot of data. You would like to reduce it, okay? You would like to deploy it to the module itself, and you need to prepare it, okay? This is the part of optimization, let's call it. Okay, we are optimizing how to use a lot of resources, like GPU resource. You need to optimize the data so it will not be overwhelmed. Otherwise, it doesn't make sense. And then we are talking about the module itself. Now, module customization, this is usually where we are talking about AI, where the modules are coming from the customer itself. They are building a module that's running. For example, what you are familiar today, they are talking about a lot of LLM, ChatGPT, all sorts of modules that are running in order to provide you the training. What the module will do is that it will learn a lot of patterns. Okay, for example, it will know to detect a dog out of millions of pictures. Someone will train him to do that. The module will train him to do that, to detect one picture out of millions, and we know that this is a dog, and then if we will see another dog, we'll say, yes, this is a dog, or this is a cat, or this is not a dog, okay? So this is the training, this is what we are talking about, the module. Now, information retrieval. This is like when we are talking about, here's another, this is where the UI is coming apart. So if you are familiar with ChatGPT as an example, you are writing a text, and somehow you are getting an answer. This somehow is that once you're writing a text, someone needs to understand the text and go into the module and the database and try to retrieve this information, okay? So this is part of it, okay? What you can see here is the three parts that we are talking about. So I'm getting the data, I'm trying to understand that as part of the inference, I'm trying to understand the data, and then if the data is valid, for example, if I'm retrieving a data that you are not supposed to see, the guardrails will take care of that. Will say, hey, you're not supposed to see this data, or this data is not meant for you, and I will not retrieve the data for you. For example, if you will try to understand how to build a bomb, it will be stopped here. Okay, I will not provide you the data, because this is part of the rules of the system. So this is how AI is working in a very high level blocks, okay? So what we saw is that we have a lot of training data. Think about Tesla, a tremendous amount of data that is coming in to the data center. It needs to be compute. There's a lot of computation running on it, okay? Just to move the data from one data set, one node to the other, do the computation, check it, retrieve it. A lot of computation here. This is the training that we just saw, okay? And this is the expertise. In the end, I'm providing you the data. Someone needs to know how to run this AI component on it, these modules that we just discussed. So someone is building these modules, someone is running them to provide you all this data. This is the building blocks. And if we will try to put a little bit more color to it, okay, maybe I can do it with this. So what you can see in here, this is our component. So we have the training that we discussed. Probably it will work like this. This is the training that we discussed, okay? All sorts of cloud vendors that you can see in here. These are the cloud vendors that can be holding all the data, okay? The training that we discussed, this is the data curation, the modules, the training, everything is in here, and the expertise. In the end, this is the source that will come from the vendor that will deploy that. These are the building blocks. This is how you can build an AI. If you look in here, this is how it looks. This is an AI cloud. This is how it looks in reality. A lot of building blocks of servers, storages that are connected together in a very, very high speed connection, what we call about NVLink or GPU Direct, all sorts of stuff, just to be able to move the data from one node to the other as fast as possible, because a lot of GPUs are needed in order to run all these modules and provide you the data that you wanted. So you put it in one place in a very high speed link. So this is it about AI. Now let's start looking about what we can do about AI that needs the timing. Okay. So if you remember, we are looking on the training session. In the training session, you have a lot of information that you need to spread through a lot of nodes. This is what we call all-to-all. So you have one data that you need to spread for all nodes, so because they need to do their calculation on the GPU. For example, you use NVIDIA Collective Communication Library, what we call Nickel, or Magnum IO, all sorts of software acceleration to spread the data between the nodes. But once you are starting to spread a lot of data between the nodes, doesn't matter which transport you are using, you are bound to congestion. Okay, and if you have congestion, it means that some data will be skipped and you will not be able to utilize the entire network. Okay, in order to reduce that, you can use a congestion algorithm that will be based on timing. Instead of the current traditional congestion algorithm, you can use a timing based. And if you use a congestion algorithm time based, it means that you are, if I would just articulate it, you will open a window. Sending a data, you will open a window, in which window is measured in time, okay, when you can send the other time. And there will be a window for opportunities for everyone. And that by that, you can save some time, okay? If you will save, like, let's say 5%, 3% of the time in that large scale, it's tremendous amount of money. We are talking about now need to have a granularity of nanoseconds of accuracy in order to save number of small percentages in the entire data center to save millions of money. Because every time that there is no data that is coming and floating, okay, it's a waste of money from the entire data center. So we are trying to do something like that. This is something that we are currently as experiment running in our lab, using timing to reduce congestion time. Other simple stuff that we are familiar with is distributed databases. Okay, if you remember at the side of the training of the data, there is a lot of data coming into the database. You need to distribute the data into the database. Okay, in order to do that, for example, if someone is doing a lot of operation of read and write, it will be blocked. This is database normal operation. But there are other ways of doing that. For example, Google Spanner, okay, are doing ways of using time in order to get more certainty into the database. That means that instead of just sending the data and doing polling all the time, trying to read if the data is there, if I can do another write, do another write operation, you will have time-based, timestamp, sorry, going back. You will have a timestamp for each operation. And the timestamp will be all, for example, all the database will be synchronized. That means that this timestamp will be known to everyone. That means that if I put a timestamp as a UTC format in the world time clock, every other servers will know that this is a unique time. This is something that we are familiar. And if you have a timestamp per transaction, you know if the current database that you have is set or not, if it's updated or not, because if it's the time in the past or in the future. You will know that, and based on that, you can update your database. This is like a very sophisticated way of updating database that required for AI without doing the polling mechanism, just doing timing mechanism. On top of that, okay, we can add telemetry. Okay, so we have all these sources of data, we have all this database, but in the end, trying to understand where the time is spent, trying to understand if we are missing something, we can use telemetry data. So if you have a very accurate timing in the database, that means that every transaction can be timestamped, every telemetry information can be timestamped. Now you can correlate the entire database. Every node will provide you the telemetry information. For example, how many transactions. You can see here the time it takes for each transaction on the GPU or on the CPU. Now you can correlate number of nodes together to one picture. And if you can correlate that, you can see that, yes, for example, here we have a dead time in example. A time that nothing happened. If nothing happened, that means that the server is not utilized and we wasted something. So this is really important in order to utilize the server in a more efficient way. What you can see here is, this is the topology of something like that. We have a grandmaster to provide you the world time clock. This is just an example of 2 switches and a full topology of DGX server. All these server will be locked to the PTP. We'll have a timestamp from the UTC, okay? And by that, you can correlate everything. Each node in here will send the telemetry to one node. You can see here, for example, we have a system. This is like NVIDIA Insight and NetQ. All these 2 systems provide you a way of collecting all the telemetry and all the information and understand the data center topology right now and the time spent. Okay, so I gave you 3 examples about how to use timing in AI today. Okay, we had the first one was congestion algorithm that can be saved, that can use by timing and reduce a small percentage, but very, very important percentage of the congestion by that. We have a database like a Google Spanner, distributed databases that are based on timing, a very, very accurate timing. We're talking about nanoseconds of accuracy. And on top of that, you are adding the telemetry to understand the utilization of the database. Any questions or more information?